In this video, we'll be graphing a linear inequality in the plane, and these are going to be in slope-intercept form. Okay, so recall what slope-intercept form is. Y is equal to mx plus b. Okay, so without the inequality, and we will deal with the inequality in a minute, if it's in slope-intercept form, m is your slope, and b is your y-intercept. Okay, given that, and given that these are already in slope-intercept form, you should be able to graph these pretty quickly. Okay, one other thing I want to mention before we start this problem is the inequality sign. If you have these types of inequality signs, that's going to be on the coordinate plane. That's going to be a dotted line. Okay, and if you have this or this, it's going to be a solid line. Okay. All right, so notice on this one, we have just the less than sign. So when we graph this thing, we're going to use a dotted line. Okay, so let's see. On this problem, we have our slope is equal to -1/2. And remember, that's rise over run. That can be written as down 1, right 2, or it could be written as up 1, left 2. Okay, so we can use either one of those slopes. So that's -1/2 can be written in either one of these ways, and it's rise over run. Okay, and our y-intercept, our b, is equal to -4. So -4 on the y-axis is where we're going to put our first point. So let's go to the y-axis. We go to -4. I put a dot right there. And now I'm going to use my slope, both of them. I mean, we have one slope, but both ways that it's written. If we use this one, it says go down 1 and then right 2. So down 1 and right 2 would be here. I can use a couple of those, down 1, right 2, down 1, right 2. Keep going that direction. You could also use this slope, which says up 1, left 2. So go back here, up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2. And you see that that's basically the line. Okay, so I'm going to put some dotted lines there. This is a dotted line, not a solid line because it does not have the equal to sign on the bottom of the inequality. Okay, so there's my line. That is the line y is equal to -1/2 x minus 4. Okay, now which side do I shade? Do I shade above or below? Okay, one way of thinking about it is that this says y is less than this line. Less than, down. Okay, another way of thinking of it is just plot a point in either side of this line. Just pick a side, doesn't matter, above it or below it, over here, over there, and see if it's true. Okay, so if I choose a point, let's say 0, 0 is always a good one to choose because they're all zeros. So 0, 0 is in this region. So if I plug in 0, 0 and it's true, then that's the side I want to shade. Okay, so is this true? Is 0 less than -1/2 times 0 minus 4? Is that true? Okay, so let's see. 0 less than -1/2 times 0 just goes away. So is 0 less than -4? No, that's false, right? That's false. So since that's false, we know that this point is not included in our answer. Okay, so we can't shade it. Since I plugged in 0, 0, and it's an inequality that's not true, it's false, then I know I can't shade in this area because that point was from this area. So instead, I have to shade below the graph. So I'm going to shade this region down here. This is the region I want to shade for this problem. Okay, let's take a look at another one. So on this one, we've got y is greater than -3x plus 5. Okay, so we have our slope. Our slope, which is our m, is -3. I'm going to put it over 1 because, rise over run. Could also be written as 3 over -1. Okay, the two different ways to use our slope. This is down 3, right 1, or up 3, left 1. Okay, and my y-intercept is going to be 5. So that's where I start my graph. So I'm going to go to 5 on the y-axis. Here's 5 on the y-axis. I put a dot. Now I'm going to use my slope to get some other dots. So let's use this one first. Down 3, 1, 2, 3 over 1. Down 3 over 1. Down 3 over 1. Down 3 over 1. Down 3 over 1. Okay, and I can also use up 3, left 1. So go back here. Up 3, left 1, up 3, left 1, okay? So there's the basic graph. I'm going to put a dotted line because there's no line underneath here. There's no equal to. So this is be a dotted line. So let's see if I can keep that on track there. Dotted line, dotted line. There we go, okay? Now let's see if I can try point. Now 0, 0 is always the easiest one to try, okay? So let's see if 0, 0 is included in our solution set. If it is, if I get yes, then I'll shade this side. If I get no, then I'll shade the other side. So we're going to try, again, try 0, 0 for x comma y, okay? So I plug that in and I get 0 is greater than negative 3 times 0 plus 5. This, of course, goes away, so 0 is greater than 5. Is that true? Nope, that's false. That is false. 0 is not greater than 5. So we know that this region right here is not in our solution. So if that region is not in our solution, that means the opposite side of that line must be in our solution. So we will shade this side. We tried 0, 0. It wasn't in the solution, so we shaded the other side. Okay, let's do a couple more. On this one, we have y is greater than or equal to negative 1/3 x minus 2. Okay, so for my slope, I have negative 1 over 3, or I could write it as 1 over negative 3. And for my y-intercept, I have negative 2. Notice that I have a greater than or equal to sign here. And remember, that's going to equate to a solid line. Okay, so let's start at negative 2 on the y-axis. That's right here. And let's use our two different ways of writing our slope here. First one says down 1, right 3. Down 1, right 3, down 1, right 3, down 1, right 3, and then down 1, right 3. We could also use up 1, left 3. So up 1, left 3, up 1, left 3, up 1, left 3, and one more up 1, left 3. Okay. Now on this one, I am going to put a solid line. So let's see if I can draw this thing. Keep on the lines pretty good here. This is a solid line that I'm going to draw here. Okay. So I'm drawing a solid line because the inequality had an equal to right here. Okay, and now I want to test which region? I'm going to test 0, 0. Okay, 0, 0 is right here. So if I plug in 0, 0 and it's true, then I'll shade this side. If I plug in 0, 0 and it's false, I'll shade the other side. Okay, so is 0 greater than or equal to negative 1/3 times 0 minus 2? So this goes away. Is 0 greater or equal to negative 2? Well, it's not equal to negative 2, but it certainly is greater than negative 2. So this is true. Since that's true, then the side that contains 0, 0 is the side that gets shaded. So I'm going to shade up here. Okay. One last problem. We've got y is less than or equal to negative 5x plus 4. So our slope is equal to negative 5. I'm going to put it over a 1. Could also be written as 5 over negative 1. And our y-intercept is going to be 4. Okay. Again, we have an equal to sign under here. It's less than or equal to. So remember, that's a solid line. That's what we're going to do there. Okay, so let's go to 4 on the y-intercept, so 4 on the y-axis. Plot a point. Okay, and then we're going to use our slope. So this one says down 5, right 1. 1, 2, 3, 4, 5, right 1. 1, 2, 3, 4, 5, right 1. 1, 2, 3, 4, 5, right 1. And then I could also use this one, which is up 5, left 1. 1, 2, 3, 4, 5, left 1, and that's about it. And I'm going to put a solid line there. Do my best to keep this thing straight as I can. Okay, it's not perfect, but you get the idea. There's the line. Now let's test. Here's 0, 0. So it's over here. If this is true when I plug in 0, 0, I'm going to shade this side. If it's false when I plug in 0, 0, I'm going to shade the other side over here. Okay, so test 0, 0. When I plug in 0, 0, I get 0 is less than or equal to negative 5 times 0 plus 4. This goes away. 0 is less than or equal to 4. Is that true? Well, it's not equal to 4, but it's definitely less than 4. So yeah, that's true. This is a true statement. So we are going to shade the side that contains 0, 0, which is this stuff over here to the left. So this is what I will shade. And that's it.